This is another example of the round robin algorithm. Consider the following processes with arrival time and burst time. Calculate average turnaround time, average waiting time, and average response time using round robin algorithm with quantum theory. So in this example, you have to find the average turnaround time, waiting time, and response time. So what is turnaround time? Turnaround time is the time taken by a process from entry to exit. It means the process enter into the system and exit from the system. The time taken during the execution and entry to exit, right, is called the total time taken by a process in the system is called turnaround time, right? Waiting time, the process wait in the system, right? Response time from entry to first response, right, is called response time. So let's start to calculate these all the time taken by a process, right? So there are 6 processes in the system: P1, P2, P3, P4, P5 and P6, right? This is the arrival time. So at 1, P4 enter into the system. So P4 is the first process that arrive at 1. So the execution will start from P4, but P4 before P4 there were no any process in the system. Remember this point, because from 0 to 1 CPU was idle, right? So 0 to 1 CPU was idle here, 0 to 1. So the CPU will start from 1 to execute P4. So P4 will execute from 1 to 4, right? Because quantum is 3. So 3 times it runs and remaining 6, right? Then P5 will start to execute P5 and P5 will execute completely 2 times up to 6, right? Then P3 will start to execute and it will execute up to 3 times. Okay, so 4 is remaining. Then P2 will start to execute and P2 will execute up to 12. 3 remaining. Then P1 will start to execute and P1 will execute up to 15 and 2 is remaining. Then P6 will start to execute and P6 will execute up to 18 and it will out from the system, right? Now there are 4 processes in the system. So P4 will start to execute again P4 and it will execute up to 21. 3 is remaining. Now P3 will start to execute and P3 will execute up to 24. Then P2 will start to execute and P2 will execute up to 27 and P2 will go exit. Then P1 will start to execute and P1 will execute up to 29 and P1 will also out. Then P4 will start to execute again and P4 will execute up to 32 and P4 will go to exit. Then P3 will start to execute and P3 will execute up to 33, right? So this is the whole process of the round robin algorithm. Now you have to calculate turnaround time. Okay, so first of all we will calculate turnaround time. Total turnaround time. Okay, total turnaround time is equal to start from P4. P4 enter into the system at 1 and P4 exit from the system at 32. See, P4 enter into the system at 1, okay, and P4 exit from the system at 32, okay. P4 exit from the system at 32. So the total turnaround time for P4 is 31 because P4 enter into the system at 1 and exit from the system at 32. So the total time taken by P4 is 31, right? 31 plus P3, P5, sorry. P5 enter into the system at 2. Remember here, this is the arrival time. P5 enter into the system at 2 and P5 exit from the system at 6, right? So P5 enter into the system at 2 and exit from the system at 6. So the total time taken by P5 is 4, right? Then P3 enter into the system at 3 and P3 exit from the system at 33. See here, P3 enter into the system at 3 and P3 exit from the system at 33. So 33 minus 3 will be 30. So P3 turnaround time is 30. Then go to P2. P2 enter into the system at 4 and P2 exit from the system at 27. So 27 minus 4 is 23. So P2 exit from the system at 27, right? So the total turnaround time of P2 is 23. Now P1 enter into the system at 5 and P1 exit from the system at 29. Okay, so the total time taken by P1 is 24. Then the last P6 enter into the system at 6 and P6 exit from the system at 18. So 18 minus 6 is 12, right? So the total turnaround time taken by the process is 31 plus 4 is 35 plus 30 plus 23 plus 24 plus 12. The total time is 124. And the average turnaround time is equal to 124 divided by how many processes in the system? 6. So 124 divided by 6. So the total turnaround time, average turnaround time is 20.67. Okay, so this is the time, this is the average turnaround time. Clear? I hope you all understand this turnaround time. Now the total waiting time, you will calculate total waiting time is equal to what is the waiting time of P4, or start from P1 to P6, no problem. So P1 enter into the system at 5, okay, and P1 start the execution at 12, okay. So 12 minus 5 is 7. So P1 waiting time is 7, right? But P1 doesn't complete their execution yet. P1 will start again at 27, right? So from 15 to 27, this is also the waiting time of P1, right? So what is the waiting time here? 27 minus 15 is 12. So 7 plus 12. This is the waiting time of P1, right? Then plus P2. P2 enter into the system at 4, okay, and P2 start the execution at 9. So what is the waiting time here? 9 minus 4 is 5. So 5 plus P2 doesn't complete yet, okay. So P2 will start again at 24 So P2 12 to 24 is the waiting time of P2, right? So this is also the waiting time of P2, 12 to 24. So the total waiting time of P2 is 12 here. So 5 plus 12, this is P2 waiting time. Then P3 enter into the system at 3 and P3 start the execution at 6. So 6 minus 3 is 3. So the first waiting time of P3 is 3 plus P3 will start again at 21. So 9 to 21 is the waiting time of P3. So this is also 12. But P3 doesn't complete yet. So P3 will start the execution again at 32. So from 24 to 32 is also the waiting time of P3, right? So 32 minus 24, it's 8. So this is the total waiting time of P3, right? Now plus P4. So P4 enter into the system at 1 and P4 start the execution at 1. So there is no waiting time here. So for the P4, first waiting time is 0 and another waiting time here from 4 to 18. Okay, so from 4 to 18 is the waiting time for P4. So it's 14. So 0 plus 14, but P4 doesn't complete yet. So P4 will also wait from 21 to 29, 8 times. Okay, so this is the total waiting time of P4. Then P5. So P5 enter into the system at 2 and P5 start the execution at 4. So 4 minus 2 is 2. So P5 waiting time is 2 only, right? So P5 will complete here and P5 will not execute again because the burst time is just 2. Then P6 enter into the system at 6 and P6 start the execution at 15. Okay, and it will complete here. So 15 minus 6 is 9. So 9 waiting time for P6, right? So the total waiting time is equal to 7 plus 12, it's 19, plus 5 plus 12, it's 17, plus 12 and 8, 20, 23, plus 14 and 8, 22, plus 2 plus 9. So the total waiting time is 92. And average waiting time is equal to 92 divided by 6. So divide by 6, it will be 15.33. This is the waiting time, average waiting time. Okay. The third question is average response time. So what is the average response time here? So we will find first total response time. Okay, so from entry to first response, right, is called response time. For example, P1 enter into the system at 5 and P1 start the execution at 12. So 12 minus 5 is 7. So the response time for P1 is 7. Okay, so this is the response time of P1. Then P2 enter into the system at 4 and P2 start the execution at 9. So 9 minus 4 is the response time of P2. So 9 minus 4 is 5. 5 is the response time of P2. Then P3, what is the response time of P3? So P3 enter into the system at 3 and P3 start the execution at 6, right? So 6 minus 3 is 3. So 3 is the response time of P3. Then P4 enter into the system at 1 and start the execution at 1. So the response time of P4 is 0. Okay, so it will start immediately when it arrives. Okay, so P5 enter into the system at 2 and start the execution at 4. So what is the response time of P5? 4 minus 2 is 2. So the response time of P5 is 2. P6 enter into the system at 6 and start the execution at 15. So the response time of P6 is 9. Okay. So the total response time is 7 and 5 12 and 3 15 and 2 17, 17 and 9. Okay, so total response time is 26. So what is the average response time? Average response time is equal to 26 divided by 6. So 4.33 is the average response time. Okay, so that's all. So if you have any question, you can comment on the video. So I hope you all understand this question. Okay, thank you for watching.